Hey all, welcome to Homeschool ICSE channel. So here in a channel, we will complete all the topics from physics, chemistry, biology and mathematics from classes 8th to 10th. So no need to worry about these subjects. You will get all your doubts cleared once you watch the topics in our channel. See, already few chemistry chapters are there in a channel for class 8th, 9th and 10th. And today I am with the first chapter of class 10 chemistry, that is periodic table, periodic properties and their variations. Clear? Not only for ICSE board, other board children also can watch the content in a channel. See, most of the contents will sync with your syllabus. Definitely, your class 11 and class 12 concepts also you will find in a channel. Where the ICSE 9th and 10th syllabus is similar to CBSE class 11 and 12. So for any basic foundation, for any topic, if you want your basic things get cleared, you can watch this channel and share the content with all your friends so that everybody get benefit out of it. So do subscribe our channel to have a better learning experience. Fine. So let me start the chapter quickly. It is periodic table, periodic properties and their variations. One of the very important chapters of chemistry, I can say, not only for the 10th, and this is the most fundamental chapter to understand various concepts of chemistry further. Okay, so concentrate towards the chapter. Each and every topic in the chapter is really very important. Fine. So we all have an idea about periodic table. Say we will have a very nice, beautiful, colored table behind our textbooks or within the textbook, isn't it? Inside a textbook. So that particular colored table itself, we will call it as periodic table. So can you all able to recall, so why this table in chemistry? So what is the use of this particular table in chemistry? So what is mentioned in a table? Say you will have so many symbols, right? Say many elements which can be naturally present or the elements that have artificially synthesized have been mentioned in that particular table, isn't it? Say there are so many elements in our nature. So by the way, what do you mean by an element? Element is the pure substance which is made up of atoms of same type, right? So elements will have lots of atoms. When atoms from different elements combine, you get so-called chemical compounds or chemical substances. So that's the reason every day thousands of new chemical compounds are being synthesized, is just because the atoms from different elements have an ability to combine. Right? Say for example, you have NaCl. So how is this NaCl formed? It is formed by the combination of sodium atom and chlorine atom, isn't it? Say sodium is one element, chlorine is other element, right? So atoms from these elements have combined and you're getting a chemical compound called NaCl. So I can say the element is the purest substance which is made up of crores and crores of atoms, right? And it is very much necessary to understand certain properties of these elements. And you can understand all those properties with the help of periodic table. Okay, so now let me give you the definition of periodic table, right? So periodic table is nothing but elements. It is the arrangement of elements, I can say. So all the elements are beautifully arranged in a particular format according to a particular theme. Okay, so they are not arranged however they want. Okay, so scientists have studied about each and every element based on their chemical and physical properties. They have arranged all these elements in a beautiful format. Okay, so that arrangement of elements in groups and periods. Okay, groups and periods. I'll tell you what do you mean by groups and periods. Okay, so where the properties of elements are repeated at regular intervals. Okay, this is really a very, very important sentence to understand. So properties are repeated at regular intervals, right? So this is what I can give as a definition of periodic table. Okay, so it is the table which includes the arrangement of elements in groups and periods. I'll tell you what exactly this group and period is. And here the properties of elements are repeated at every regular intervals. Okay, so after certain gaps, the same property will get repeated in the periodic table. So that's what we mean by this particular word. Clear? And now let us study about the modern periodic table. Right from 17th century onwards, different scientists have put up their own periodic tables according to their own theme. Okay, so like that in our syllabus, actually in your previous class, that is in class 9, you studied about Dobryner's triads, right? So this is the very oldest periodic table introduced by Dobryner's. Say you must have studied that the elements are arranged according to atomic mass in the form of 3, okay, group of 3. So group of 3 is called as triads actually. So that was the oldest periodic table, but lots of limitations are there. And so came the next periodic table. What is that? Newland's law of octaves, right? Say here he has arranged the elements as a group of 8, isn't it? Say where the property of first element is similar to the 8th element, just like the musical notes. Sa is the first note, re, ga, ma, pa, da, ni, sa. Again the 8th note is sa. First note and 8th note is similar, right? Like that, the first element's property is similar with the 8th element. All that I don't go in a deeper way, just it's a quick recall for you all. And next, the third periodic table that we studied was Mendeleev's periodic table. Okay, so this somehow looks similar to our present periodic table, that is a modern periodic table, isn't it? So this was Mendeleev's periodic table, where he arranged the elements in the increasing order of atomic masses, right? And later we are going to study the present periodic table, that is modern periodic table. So these 3 periodic tables are the history of periodic table. Okay, actually our modern periodic table is 46th periodic table. So we are currently following 46th periodic table, right? That is the most accepted periodic table which we are using. And before that, 45 periodic tables were having one or the other limitations, so we stopped using them. So among the 45 periodic tables, 3 important periodic tables you will study as history. Okay, so these 3 you have already studied in your previous classes. Now the entire chapter is about our modern periodic table. Okay, so let us now learn salient features of modern periodic table. Okay, and this modern periodic table was introduced by a person called Moseley. Okay, so Moseley is the one introduced modern periodic table, and this is completely based on atomic number. Okay, and you have a definition that you have to know, very, very important. I can say our modern periodic table is based on modern periodic law. Okay, so this definition is really very important. So try to note down each and every point in your book so that it helps you for the learning. Clear? So let me give you the definition here. The physical physical and chemical properties. Chemical properties, let me write it here. Properties are the periodic functions of their atomic number. Okay, so what do you understand by this sentence? Atomic number. This is the key word that you have to remember. It means that the elements are arranged in the increasing order of their atomic number. Okay, so the chemical and physical properties entirely depend on atomic number, and the same properties of elements gets repeated in the periodic table after certain gaps, after certain intervals. Okay, so that is the exact meaning of modern periodic law. Clear? And you would understand the exact meaning of this when you look at the periodic table and when I explain it in detailed way. Clear? Now let us go for drawing a periodic table. See, you have to know how to draw a periodic table. You must be having the periodic table in your book. It's better that if you keep periodic table chart in front of you when I start teaching this periodic table. And here I am going to draw and I am going to tell you which important elements that has to be remembered in a periodic table. Clear? Let us quickly go for that. See guys, as I already told you, all the elements are arranged in the form of groups and periods, right? So you must clearly understand what do you mean by groups. Groups are nothing but vertical columns. Okay, vertical columns are called groups and there are 18 vertical columns. Okay, so this is how. Vertical columns are 18 in number. They are called as groups. And coming to periods. So periods are nothing but horizontal rows. Horizontal rows. Yeah. So there are 7 horizontal rows. So this is how. This is what we call horizontal rows and there are 7 in number. They are called as periods, right? And now let us try to draw those groups and periods. So how many groups I told you? 18, right? So let me draw them. Say this is our group number 1. Okay. So group number 2. So just I'll give a particular shape here. So group number 3 will start here. Okay, so this is group number 3, group number 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, and group number 13, again something like this. 13, 14, 15, 16, 17 as well as 18. Okay, so you can draw along with me so that it becomes a practice for you. It's better to draw and practice, right? So these are our 18 groups. Okay, so let me just give a numbers. So this is 1, 2, 3, 3 to 12. Okay, and this is 13, 14, 15, 16, 17, 18, right? So these are our 18 groups. And coming to horizontal rows. So how many horizontal rows? That is how many periods are there? 7, right? Okay. You observe the first period, guys, and the first period is a very small period, okay, which includes only 2 elements. So this is our first group, okay, and this is 18th group. So this is a very small period. Okay, so this is the first period. Clear? And this is our second period. Can you all able to tell me how many elements will come in second period? 1, 2, 3, 4, 5, 6, 7, 8. 8 elements will come in second period. Similarly, 8 more elements can be arranged in third period. Clear? And coming to this one, quite bigger period, almost around 18 elements can be arranged, in fourth period. Clear? And this is our fifth period, and this is our sixth period, and this is seventh period. Okay, so this is how a table will have 18 vertical columns, that is 18 groups, and 7 horizontal rows you have, they are called as periods, right? And now I am arranging all the elements in this particular table. Okay, so as I already told you, elements are arranged in the increasing order of their atomic number, right? So the first element with atomic number 1 is hydrogen. So hydrogen comes here, and the next element with atomic number 2, helium, comes there. Okay, so atomic number 1, atomic number 2. Now atomic number 3 element is coming here in the second period. Okay, so here comes your lithium, here comes your beryllium, atomic number 5, and then atomic number 6 is for boron, right? Atomic number 5 is for boron, atomic number 6 is for carbon, right? 7 is for nitrogen, 8 is for oxygen, then 9 is for fluorine, 10 is for neon, and then the 11th element comes here, that is sodium, right? And here comes your magnesium, and below boron comes aluminium, here silicon, here phosphorus, here sulfur, here chlorine, and here argon. Okay, so like that I will just fill up few elements. You can observe, see, in the first group the elements are hydrogen, lithium, sodium, potassium, rubidium, and cesium. Okay, and one more, francium, is a radioactive element. And coming to the second group, the elements are beryllium, magnesium, calcium, strontium, barium, and radium, right? And now let me go for the 13th group. Okay, so boron, aluminium, gallium, indium, and thallium, right? And here carbon, silicon, germanium, tin, and lead. Clear? Nitrogen, phosphorus, arsenic, antimony, and bismuth. And coming to 16th group elements, oxygen, sulfur, selenium, tellurium, polonium, chlorine, bromine, iodine, astatine. And coming to noble gases, helium, neon, argon, krypton, xenon, radon. Clear? So these are your 13th to 18th group elements. And coming to here in this category, after calcium you have this is atomic number 20, and here comes your atomic number 21, scandium. Okay, and then titanium, vanadium, chromium, manganese, iron, cobalt, okay, nickel, copper, and zinc. Clear? And now, you know what, this is how all the elements are arranged. And one more thing I want you to be clear. Look at here, guys, this is your 56th element, and here 57th element, that is lanthanum, is there. And after lanthanum you will suddenly have the 72nd element, okay, that is hafnium. So guys, where are the elements gone from 58 to 71? So almost around 14 elements, isn't it? So where are these 14 elements gone? Right? So that comes a doubt here. And similarly, coming to the 7th period, okay, and here actually radium's atomic number is 88. So after radium, here it comes 89th element, that is actinium. So after actinium, 90th element must come here, right? But you will suddenly find the element with 104 atomic number. Okay, so that is Rutherfordium. So again here, you see. So here the elements from 90 to 103 is missing, right? Again these are the 14 elements. Again they are the 14 elements. So where are these elements gone? Comes a big doubt, isn't it? So Actually, see here the 14 elements, that is from atomic number 58 to 71 is missing, and then atomic number 90 to 103 is missing, right? So these elements, since they have different properties, they are placed separately below the periodic table. Okay, so let me mention those elements also. So they are placed separately below the periodic table. So observe here, actually in your textbook, if you observe, there are two rows, special rows mentioned below the periodic table. Okay, so the first row includes the elements from lanthanum. Okay, after lanthanum comes your element cerium. Okay, so lanthanum is having an atomic number 57, cerium has atomic number 58. So from cerium to lutetium has the atomic number 71. Okay, so these elements are called with the name lanthanides. So why they are called with the name lanthanides? Because these 14 elements, cerium to lutetium you consider, that is from atomic number 58 to 71 you consider 14 elements, they are placed after lanthanum. That is why they are called as lanthanoids. Okay, so lanthanoids means the elements which are coming after lanthanum. Similarly, you see the next row includes the element actinium. Actinium atomic number 89. Okay, so after actinium comes the element thorium with atomic number 90. So atomic number 92 lawrencium, that is atomic number 103. Again these are 14 elements. You see atomic number 92, atomic number 103. So these 14 elements are called with the name actinoids. They are called with the name actinoids. Actually, where do they come? They will come in third group. They are coming in third group, sixth period. Okay. So actually, where does this lanthanoid come? They are placed in third group, sixth period. Okay, that is their position. Since they have different properties, since the structure of periodic table, shape of periodic table gets destroyed, it becomes irregular. Just to avoid that, they are placed separately below the periodic table. That's it. Okay, so here, where is the position of actinoids, guys? They are coming in third group. They all will come in third group. And which period? Seventh period. Okay, so this is the position of lanthanoids and actinoids, right? So actually, if you can remember these many elements for your 10th grade level, this is more than enough. See, I didn't fill all the elements. See, all of them are not necessary. At least the elements that I mentioned on a board is very, very important to remember. Clear? So this is how the elements are placed in our periodic table. So now, let us learn about some different names. You know what? Each group is called with one special name in the periodic table. Clear? So each group has one special name. And remember, the elements which come in same group has same chemical and physical properties. That is the most important thing one must understand. Okay, so let me write that point here. So note down all these points. Elements which come in same group has same properties. Okay, so this is what the meaning of the definition of modern periodic law also. See guys, in the definition of modern periodic law, we studied a sentence that chemical physical properties are repeated at every intervals, isn't it? So it means that, you see, lithium is here. After certain gaps, after certain intervals, you have sodium. So below sodium you have potassium. So potassium has come after certain gaps, after certain atomic numbers or intervals, right? So the elements which belong to a same group, after certain gap, the same physical and chemical property got repeated. Okay, so that's what is the meaning of the definition, right? So that is why we say the elements which are present in a same group will have same chemical properties. Hydrogen, lithium, sodium, potassium, rubidium, all of them react in a similar way. Similarly, beryllium, magnesium, calcium, strontium, barium, all of them would react in a similar way. Okay, so this is what we mean by elements which come in same group has same physical and chemical properties. Okay, fine. And you know what? Elements which come in same group will have same valency also. So let me write that point also. Elements of same group has same valency. Okay, so you all have an idea about valency, right? It is the number of electrons lost or the number of electrons gained during a chemical reaction. So usually when elements participate in chemical reaction, they either lose electrons or they either gain electrons. Okay, so this losing and gaining capacity of atom or element is called as valency. So about this we will discuss more in the next video, so don't worry about that. So just elements which have same group has same valency. Okay, and maybe what is the reason for all this? Why they have same chemical properties? Why they have same valency? It is because they have similar electronic configuration. Okay, so what is the reason for these things? It is because they have similar outermost electronic configuration. Clear? So this is the reason why they have similar chemical and physical properties. Say, what is the electronic configuration of hydrogen? It is 1s1, outermost, right? What is the electronic configuration of lithium? It is 1s2, 2s1. You see? In the s orbital, you have one electron for hydrogen. Lithium also, in the s orbital, you have one electron. Similarly, if you write the electronic configuration of sodium, outermost one will be 3s1. For potassium, 4s1. For rubidium, 5s1. You see, the outermost electronic configuration is similar for all the elements present in a same group. Maybe because of that, all elements have same valency. All elements have same physical and chemical properties. Okay, so this is really a very, very important point one must remember. Clear? Fine. And now each and every group is different because all elements in the group behave in a similar way. We understood. Now each and every group has one set of different properties. Based on their properties, they are given with different names. Okay, they are given with different names. And now let me give you the names of different groups here. Okay, so hope you have copied all these points. And now I am giving you different names for the groups. See guys, here the first group elements are called with the name alkali metals. Okay, say why do we call them as alkali metals? Because they form water soluble bases. So usually water soluble base is called with the name alkali. Okay, for example, sodium, right? First group element, I took sodium as an example. When you add this into water, you will get the base NaOH, and this base is soluble in water, and this is called with the name alkali. Okay, so every element, lithium, sodium, potassium, rubidium, the moment you put them in water, you will get water soluble bases. Okay, so that's the reason they are called with the name alkali metals. Okay, fine. And coming to second group elements are called alkaline earth metals. They are called alkaline earth metals. Okay, it is because these elements, beryllium, magnesium, calcium, they are all present in earth crust. Okay, even these elements also, when they dissolve in water, they will give alkalis. So here two meanings are combined. One is they are present in earth crust in the form of oxides mainly, and also they can give alkalis, weak alkalis, that is weak bases on dissolving in water. So that's why they are called with the name alkaline earth metals. Okay, fine. And you know, from group number 3 to group number 12, we don't call them with any special name. We commonly call them as transition elements. Okay, so from third group to which group? 12th group. They are called with the name D block elements, D block elements, or they are also called with the name transition elements. Transition elements. Okay, because they come in between S block and P block. So actually this S, P, D and all, we give these names because of the outermost electron location. Okay, so if the outermost electron is there in S orbital, we call them as S block elements. If outermost electron is there in P orbital, we call them as P block. If outermost electron is there in D orbital, we call it as D block, right? Like that, the entire periodic table is again subdivided into S block, P block, D block and F block, which you will study more about this in higher classes, so no need to worry. So just try to remember, from third group to 12th group, we call these elements as transition elements. Okay, and now 13th group elements are called as boron family. They are called as boron family. Okay, so no special name for this. Since boron is the first member of 13th group, it is called as boron family. And coming to 14th group elements are called as carbon family. They are called carbon family. 15th group elements are called nitrogen family. Nitrogen family. Okay, and 16th group elements are called as chalcogens. Chalcogens. So we call chalcogens is because they have ore forming capacity. Okay, so chalcogens means ore forming agents. Okay, see, all these elements are present in our earth crust in the form of ores. So they are present in the form of either oxides or sulfides, most of the metals. Okay, so they have ore forming ability. So they are called with the name chalcogens. So similarly, 17th group elements are called halogens. Halogens mean salt formers. Okay, so they have salt forming ability. Say sodium present as NaCl. NaCl is a example of salt. Potassium present as chloride, KCl. Okay, all fluorides, chlorides, bromides, all of them are called as salt. Okay, so salt forming ability they will show. So they are called halogens. And coming to 18th group elements, okay, they are called with the name noble gases. Noble gases. So why do we call them as noble gases? It's because they are the most stable elements in our nature and they do not react with any element that easily. So they are called with the name noble gases. Okay, and then we all know this, right? I already told you lanthanoids, actinoids. Lanthanoids means from the element lanthanum to lutetium. Actinoids in the sense from the element actinium to lawrencium, right? So these are some of the salient features of our modern periodic table. And now, very important, In which period how many elements are there is also very important concept. Okay, and coming to the first period, can you tell me, our first period has only two elements, isn't it? That is hydrogen and helium. So I can say this is the shortest period. This is the most shortest period. And coming to the second period, you have 8 elements. Okay, and third period also has 8 elements, right? Second period has 8 elements, third period has 8 elements, and fourth period has 18 elements, right? Fifth period has 18 elements, right? And coming to your sixth period, okay, this is your sixth period, and what did I tell you? All your 14 elements, that is from cerium to lutetium, belong to this particular box. Wherever lanthanum is placed, no, in that box itself they are placed. Since it disturbs the shape of periodic table, since they have a different set of properties, they are placed below the periodic table. But where do they come? They come here. So these 14 elements plus these 18 elements, altogether 32 elements are there in your sixth period. Similarly, in your seventh period also, you have a position for 32 elements. So, which is your longest period? Longest periods are sixth and seventh periods. Both of them can accommodate around 32 elements. Clear? So this is all about the basic idea on modern periodic table. So in my next class, I'm going to discuss about what is the importance of group, what is the importance of period number, concept on number of shells, and concept of valency. Okay, so do watch my next session. Definitely you will enjoy that particular session also, right? Fine. So that's all about today's video. Hope you had got all your basics clear with the periodic table. So this is the most fundamental idea on periodic table one must definitely have. Clear? So you can post your opinion in the comment about the class, and also you can post your doubts about the concept. We will try to give the best answer. So that's all. Do subscribe our channel to learn the concepts in the easiest way and in a detailed way, and share the content to a maximum students, maximum of your friends, so that everybody gets 100% benefit. Thank you so much. Meet you all in the next class.